other sheet metal forming operations are there, such as a bending in a four-side machine. You see, the same bending has been done. It's not cutting, it's not shearing. We are going to make the product with the product that we have taken in this format. We have taken the product here, which is a straight one. A straight product has been taken. A straight product has been taken there. Right? This product has been kept inside, so it is going to convert in this format, you see. First, with respect to roll bending, we have done, and it is supported, or it has been punching. Here also, when it is come this side, I want a roll. I am giving the punch here also. Force is given. Force has been given here. Force has been given in this point. Force has been given in this point. Force has been given in this point. So what happens? First the roll bended, and the left and right bending, and again the closing bending has been done to convert into the complete circled object. So how many dies we are using here? See, 1, 2, 3, 4 we are using. So that is named as a bending a four-side machine. So likewise, it is air bending. We have not used, I am free, like a stretching operations, you see. But it is not holded. In the stretching operations, we have holded the two ends. But it is free now, air bending. Just have a slightly kept aside, keeping a material above that, and started to punch. It is named as air bending treatments. So some classifications are there in the bending operations. Now I am coming to the other method of squeezing. We have talked earlier about the shearing, bending, squeezing operations. So shearing, the cutting, blanking, pasting we have done. Then later we have talked about the bending operations, roll bending, V-bending, edge bending process we have done. And now I am coming to the next operation of squeezing. This belongs to squeezing. This belongs to squeezing treatments. So this very simple we can able to understand. You see, we have taken two dies. It is in the before stage. I have kept the specimen at the between. I have kept a specimen in between, and I am going to do the pressing operation here. This die contains the design. This die contains the design. You see, the design may be like this. The die contains this, some simple design. This design is going to be punched. This design is going to be impressed on the specimens. For such cases, you see, it is a cold working sizing operations. Even though the punching is done, some force to be kept extra, because we are going to impress some designs on the object. Therefore, it is a cold working sizing operations which need more forces. But even though these more forces are given in the cold condition itself, not at the hot, that is the point here. The sheet metal form, because the thickness is 6 mm, less than 6 mm. We can able to do in the cold working condition itself. We can able to do. That is why we are not moving towards the hot working. It is used for production of metal coins. Yes, it is used for creating of metal coins. The coining process consists of die and the punch. Die and the punch. By using the punch and die, the impression and the images are created on the material. By using the punching action and the dies which contains the design. Which contains the design. Therefore, the impressions or images are created here. Created on the material. So here this is images, impression. Impression created on the metal. Using the punching and die squeezing operations. The pressure involved in coining process, it can be 1600 megapascals. It's a huge amount, huge force. The metal flows plastically and it is squeezed. You see the squeezing operation, the squeezing. And to the shape between the punch and the die what is available. The gap it will go. First I have kept like this. First the specimen has been kept, and it has to move here. It has to move here. It will be squeezed about throughout the specimen, and then it is going to create the design. So before, this is a before component, you see, before complete red. This having the design here, you see, this design is having here. The designs are here. So this designs are, these designs are here. Now it has been punched over there, and we are finally this from green color to red color showing the impressed coining operation. So likewise, the pressure is involved in the coining process about 1600. We have seen the materials causes the flow of direction of a perpendicular in force. The flow is kept a perpendicular direction. The force is applied to the object. The type of impression is formed by compressive force, compressive squeezing we are doing. The type of impression obtained in both sides will be different. For the coin, this die, this number 1 die may contain the different design. This second die may contain the different design. So accordingly, what is available in the top design, it is going to fall at the top surface of the coin. What is design available at the bottom die, it is going to fall, that impression is going to fall on the bottom side of the coin. So the shape may be, design may be different. So next we are coming to the stretch forming operations. The method of bending of tubes are like this, maybe sheets, stretch forming. The method of bending of tubes, internal metal or filling of tubes. We have seen the stretch forming in the previous slide. We have seen the stretch forming in the previous slide like this. So we have kept a tube of one strip of a sheet metal which is less than 6 mm. It has been kept, and we are giving a force here. What happens? I can able to use for tubes also to form the tubes. That is what the idea here. So this image shows that we are keeping here. We are stretching at one direction and another direction we are stretching, and we are through the tool I am going to give the stretching action. So it is going to stretch. That is okay. We have seen this. But I am doing here for the pipe also. Pipe also can be stretched. Internal mandrel or the filling of the tubes with a particularly materials such as a sand are often necessary to prevent the collapsing. What I am doing, I have taken the pipe, and on the pipe I am filling the sand, and that sand is going to give the resistance of compressive force when it is stretched out. But that sand is not capable to have 100% of resistance, but it can able to resist about 70%. Therefore, but we also need that 10 to 20% of stretching. Therefore, here I have filled the sand on the pipe, and I have hold it, and I am stretching. Here in these zones, the sand is going to give the resistance at the same time 70% only. Remaining 20% we are converting into the stretching actions. Therefore, it is going to stretch, not a cutting, not a long stretching. We need the 20% of stretching that we can able to do through these methods. It means that the sand is going to act as a mandrel in between this pipe. That is also going to collapse, but it resists and collapse. In the meanwhile, the stretching operations can be completed. So solid rods and structural shapes can be bent by these techniques. So that is how we can able to do these processes. Some of the other designs we should understand. Some bending we can do, such as some various. You see the images we will understand. Some designs we are creating here. Some designs we are creating. Likewise, some designs. Here we have bent some U bends. Here some other designs. Accordingly, the die should be there. Maybe the coiling, maybe the squeezing, maybe the rebending, maybe the roll bending, maybe the stretch forming. All together, we are forming some different shapes here. You see how it is. The sheets are created. How the sheets are created. Such how I have various bending actions I have done. Some different forming I have done. So hemming, two-stage lock seam, offset forming, joggle, channel forming. Some different actions I am doing to convert into different product by squeezing, bending, and stretch forming, coining operations. So such understanding you can able to get from this. So roll forming, one of the other method which can be useful, using the roller. Like a rolling treatment we have seen in the bulk metal deformations. Similar operations can also to be done here. So for bending continuous lengths of sheets metal in the form of large production runs, roll forming is used. The metal strip is bent, metal strip is bent in stages by passing through the series of rolls. So I have taken a sheet metal. So this is the length. This is the length of the sheet I have taken. I have kept the two rollers here. After two rollers, the thickness has been reduction lightly thickness has been reduced. But even then also, some of the side rollers I am giving. You see this image? You will understand. So here it is a very flat, somehow thickness reduction from thick to thin, from 6 mm to 5 mm, 6 mm to 3 mm, likewise. Otherwise, I am using the rollers in this format. Slightly bending also is done. Slightly bending also has been done here. And even here, furthermore it can be converted. Some other inventions I am doing here to convert, to receive multiple designs through this roller also. Rolling, roll bending, roll forming operations. Roll forming from other shapes. Roll forming operations I can able to do. So see some of the roll forming methods. Say I have taken one specimen, stage 1. Here the specimen is lightly it is changed. And second stage I have created more pressing. Here it is changed. And I have changed from here to another design. Some various punching of different. And from this, again some multiple rollers I have used to convert. Here it is straight. Here the specimen is straight. From the straight specimen, and how long I am converting, you see? Stretching, keep on and bending something and stretching some other rolling. I have changed that contains the impressions and the designs. With respect to impression designs, again I am changing. So finally product become like this. Finally product is become like this. So with some here and there some designs. So I have taken one specimen in such a format and I have divided like this and I converted like this and I finally converted in this format. So likewise some roll forming actions can be done in these sheets which are in less than 6 mm. So that is how we understand about the various types of forming processes. Now I am coming to the another process of deep drawing methods. You see, a drawing operation is the process of forming a flat piece of material blank into the hollow shape by means of a punching. So the drawing is nothing but a plate is converted into the cup format by applying the pressure here in such a way it is going to bend like this. It is going to bend like this. That is what I am going to do. At the center it will be hollow. At center it will be hollow. So a round sheet, we have taken first initially a round sheet, metal block is placed over the circular die. Round sheet has been taken and is kept over the die and we are going to punch here. When it is punched, this is going to form here. In such a way it is going to deeply and punching mechanism and therefore it forms the curve. So tumbler we can form that like that. Blank over that, the punch is forced down into the force down into the die cavity. So here is that cavity is there. So these die cavities are generated. So here the cavity. Here the cavity is there. So likewise it can be generated. A shadow drawing, there are two types of drawing operations are there. A shadow drawing and a deep drawing operation. How I am classifying this? I am classifying these deep drawing operations as which in case this diameter, let us consider we have taken a circular object which is wanted to be deep drawn or drawing operation to be takes place. This is the diameter. In case it is d by 2 less than d by 2, then I am considering this is a shadow drawing process. Which is d by 2? The depth is d by 2. What is depth? Here is the depth. So this is the depth. So this depth to be less than d by 2. In case the diameter is considered of 10 mm of diameter. So now what I have to do for this shallow drawing operations, I have taken and I'm generating a drawing operation, I'm generating the cup now. Therefore, it should be 5 mm. It should be 5 mm only. So this depth is 5 mm. So then it is called as a shallow drawing. Now for the same specimen, in case I am taking and I am going for the drawing operation which is greater than d by 2. Let us consider this depth. This depth is 7 mm. What is that? D by 2 is 5. Greater than 5, the depth is greater than 5. That is, I am naming this as a deep drawing. So shallow drawing, deep drawing, it is a difference between d by 2 less than it is shallow, greater than d by 2 it is a deep drawing operation. See, this is the same. Shallow drawing is a less than d by 2, deep drawing is a about form greater than d by 2. So here how we are doing this, we can able to have a die and a supporting packs, and then we are going to give a punch here, and therefore this operation is going to form a cup over there. So this cup is formed here. The cup is formed here. So this cup, whether it is d by 2 less than, then it is called as shallow. If it is greater than d by 2, then it is called as deep drawing. It is shallow drawing. So likewise we can able to classify this drawing operations. It is also one of the sheet metal forming process, along with the squeezing, along with the shearing, along with the blanking, punching, bending. So deep drawing also one of the squeezing methods, punching methods. So we have some different other methods. A cup is formed, see here like this. So here the die is flat here. The die is flat, therefore I am getting the product flat. Die is round here, therefore I am getting the product round. So it is open punching. So free ends are there. So it is lengthy, it is stretched out. Like this, you see, deeper. So this is how this forms. But here we have some failure. Here we have some failure there in the product due to some shrinkage efforts. So some of the various can preparation methods. You can see some plate we have taken, and the small punch keep on increasing, and finally we are forming from here we have converted into a can. Finally a can has been formed through the shearing methods. So such cans are possible by using the aluminum pieces are possible by using the deep drawing operations. What we have seen d by 2 less greater than d by 2, that I used here for cutting of the maybe Pepsi Coca-Cola cans. The summary in today's class regarding the sheet metal forming, we have talked about the various processes of shearing and bending actions. And shearing we have seen about the blanking and the piercing, and in the bending operations we have seen about V-bending and edge bending, roll bending, and then also this coining, spring back, stretch formings. So here this is squeezing operations we have seen about the coinings, and then spring backs, stretch forming, roll forming, some various topics of sheet metal forming, which is here we can able to write this belongs to less than 6 mm. Entire process are happened less than sheet metal forming. The remaining part of the subjects we will see you in the next session. Thank you.